In this lecture, we are going to discuss conditional distribution and conditional expectation. What is conditional distribution? Given two jointly distributed random variables x and y, the conditional probability distribution of y given x is the probability distribution of y when x is known. So, if there is a joint probability density function with x and y, if we know that x has taken some particular value, then what will be the distribution of y? That will be the conditional distribution of y given x. And similarly, if we know that y taken some value like that 0 or 1, then there will be only uncertainty in the value of x. How to calculate that? How to calculate the probabilities of that? That is dealt in this distribution. Let us take an example. Let we have probability density function or probability distribution function of wind and rainfall. So if there is low wind speed, then and high wind, then what will be the corresponding probabilities of no rainfall, moderate rainfall and heavy rainfall, high rainfall. So let it be like this: 1 by, when low wind, it is uniformly distributed, 1 by 6, 1 by 6, and here 1 by 8, 1 by 8 and 1 by 4. Okay, so in conditional distribution we are concerned predicting whether there is rain when one of this value happened, wind speed. Let it be high. Then, since we already know that the wind speed is high, these events cannot happen because it's with low wind speed, so all this thing cannot happen, and one of this must happen. Okay, since one of this must happen, this probabilities should add up to 1. So we know that this is the ratio of that. 1 by 8 will be for no rain, and 1 by 8 will be moderate rain, and 1 by 4 will be high rain. But we need to make it normalized. For that we need add all these three things: 1 by 8 plus 1 by 8 plus 1 by 4, that is equal to 1 by 2, and divide these numbers to make it 1. 1 by 8 by 1 by 2, that is equal to 1 by 4, 1 by 4 and 1 by 2. So please note that this ratio is same as this ratio, and only difference is this sum of these values will be 1. So exactly this what we are doing to calculate. There is an equation: conditional distribution f of x given by y equal to f of xy divided by fy of y. F of xy is given in the body, and fy of y, you know that the margin distribution is calculated here. Likewise, we can calculate also if there is no wind, what will be the probability of low rain and high rain. In a similar fashion, we need to take the row and divide some row wise to get marginal distribution and divide each element. Okay, so that's the equation for conditional distribution. F of x given y equal to f of xy divided by fy of y, that is joint distribution divided by marginal distribution, what we did. Okay, similarly in conditional distribution, continuous distribution of also y also, it will be like that. And similarly, if y given x equal to f of xy divided by fx of x. Okay, let's take an example. Let's take a discretely joined distribution. Okay. This is probability mass function. Given probability mass function, we are expressing it as this table also, the same thing. Okay, find our conditional probability distribution. So let's take how to get conditional probability for each value of x equal to 0. Y given x can be calculated by dividing this row by 1 by 4, and x given y equal to 1 can be calculated by dividing this row column by this number. That is, we need to take f of xy divided by marginals will give conditional. So we need to calculate marginals. For that we calculated marginals here. This is sum of 1 by 4 is sum of these 3, 5 by 12, 1 by 3. This how to calculate marginals. Okay, column wise added up to this number. Okay, now f of x given y equal to 1. So when y equal to 1, then that is, what is it, this column. We know this y equal to 2 is not possible and y equal to 3 is not possible. For corresponding probabilities will be 0. So y equal to 1, then what will be the probability of x? X can take 0 with the probability of, we know that we need to divide 1 by 24 divided by 5 by 24 and 5 by 72 divided by 5 by 24 and 7 by 72 divided by 5 by 24. We need to keep the ratio of this thing. That's the logic of that. Together with it should add up to 1. So probability of x1 means first column divided by fy of 1 is the margin of first column. That's all. Probability of this calculated fx by y equal to 0 for 0, 1 by 24 divided by 5 by 24, that is equal to 1 by 5. For 1, so for 1 it is 5 by 72 divided by 5 by 24, that is equal to 1 by 3. And similarly for third one, 7 by 72 divided by 5 by 24, that is equal to 7 by 15. Similarly, f of x given y when y equal to 2 can be taken as second column divided by corresponding marginal. Second column 1 by 12 by 1 by 3, that is equal to 1 by 4, and likewise each entry in second column should be divided by corresponding marginals. Okay, like this. Second column is 1 by 12 by 1 by 3, 1 by 9 by 1 by 3, and 5 by 36 by 1 by 3. You will get it like this. Okay, like this, 1 by 4, 1 by 3, and 5 by 12. Similarly, in case of y equal to 3, you need to take the third column. When probability of or conditional distribution of y given x, you know, we need to take row wise. Probability of 0y divided by fx of 0, that is first row. First row we are taking first row and divide each value by 1 by 4, that is 1 by 12 by 1 by 4, 1 by 12 by 1 by 4, 1 by 8 by 1 by 4. We get corresponding f of y equal to y given x equal to 0, because we are considering this row, x equal to 0 row only. Similarly, we can calculate x equal to 1 row for similarly x equal to 2. So that will give marginals. So that f of 0 y is first row divided by marginals, and we get the value. Likewise, let's take a continuous example, continuous case example. Let x and y are continuous random variable with joint density function fxy equal to 3 by 2 x square plus y square, 0 less than x less than 1, 0 less than y less than 1. We need to find conditional distribution of x and y. For conditional distribution, we need marginal distribution. For calculating f of x given y, we know that f of, what will be the equation, f of xy divided by fy of y. For that fy of y, we need to calculate conditional marginal distribution of y. That is, to get marginal distribution of y, we need to integrate this over x f of xy dy, that is equal to 0 to 1, 3 by 2 x square plus y square dy, that is equal to 1 by 2 into 1 plus 3y square for 0 less than y less than 1. The only thing is that we need to integrate with x. So we got the denominator margin distribution. So the only thing now we need to do is that the joint distribution should be divided by marginals, and f of x given by y equal to f of xy divided by fy of y is equal to this is numerator is f of xy, this one, and denominator is corresponding marginals, and we need to express the range for any distribution. So 0 less than x less than 1, the range. And conditional expectation. Conditional expectation is the expected value of a function of a random variable given that random variable y is calculated by expectation of h of x given y equal to y, h of x into f of x given y, x given y. Similarly, in continuous case we need to integrate. Okay, let's look at it. In general, what will be the expectation of x? Expectation of x is, in continuous case, it is integral over x or summation over x. In discrete case, integral over x into f of x. Okay, the same thing can be calculated in different way. Expectation of x equal to integral over x integral over y x into f of xy dy dx. This is another calculation for them. How it differs? First of all, you should note that these three may take different values. Okay. Actually, if x and y are independent, then this will be equal. Otherwise, these two quantities may be different. Okay. So why it differs? Because we are considering only f of x, only margin only a function of x here. Here we are considering x and y, means joint density of x and y. So in certain books, these things are noted like this: expectation here x comma y, that is they consider the underlying distribution is joint distribution. Here it is what underlying distribution is conditional distribution. That's all. If you are taking conditional distribution is also a distribution of x. You should understand first. It's derived from what? Joint distribution for a particular value of another variable. Conditional distribution of x is derived from joint distribution for a particular value of y. Okay, that's conditional distribution. So you can use that distribution also to calculate expectation. That expectation is called conditional expectation. So here we need to calculate the expectation of h of x. So in a similar fashion, h of x into what? Probability density of that thing. So for example, the joint mass function x and y is given by probability of xy equal to our earlier example is find conditional expectation of x given y. We calculated earlier this what conditional distribution for x given y equal to 1. It is like this. In earlier problem we calculated conditional distribution of x given y. This is x. Sorry, x given y. Then how to calculate expectation? Just calculate expectation using this table. How to calculate expectation using this table? Expectation of x equal to sigma x into f of x. Here the f of x is this one, that is f x by y. So this can be given by x. So expectation of x given y of x equal to 0 into 1 by 5 plus 1 into 1 by 3 plus 7 into 2 into 7 by 15. The same way we calculate expectation here. That is this equation for that, that's equal to 0 to 2 we need to multiply with corresponding probability, that is equal to 0 into 1 by 5 plus 1 into 1 by 3 plus 2 into 7 by 5 equal to 19 by 15. Okay, for a continuous case example, there also we are given probability density function, continuous density function, and we need to calculate expectation of y given x equal to 0.8. For that we need to calculate marginal of what, f of x equal to 0.8, corresponding value corresponding to 0.8, that is fx of x equal to integral 0 to 1, I think this should be in second line, fx of x equal to integral 0 to 1 f xy dy equal to integral 0 to 1 6 by 5 into x plus y square dy, that is our joint distribution. We are going to calculate marginal distribution of x, then it will be like that, 6 by 5 into x plus 1 by 3, that is equal to 0 less than x less than 1, and the conditional distribution f of xy divided by fx of x, that is we substituted the values of x here and in this value also, it would be like this, and it will be 3 by 7 into 5y square plus 4. We need to express the range of y here, 0 less than y less than 1. So it's a function of y alone. First of all, you should understand, if we know that x taken a particular value, it's a function of y alone. Okay, like that, 0 less than y less than 1, 0 otherwise. Now how to calculate expectation from this? The usual way, integral of over x, x into likewise here y is the variable, so integral over y, it will be that integral over y, y into 3 by 7 5 y square plus 4 dy, that's all. That will give integral over y. So fy so this is only joint so this is conditional distribution of that variable f y given y. So if we need to calculate expectation of y given x, we need to calculate expectation of y from this, that is equal to expectation of y equal to integral over y f x in y into y into y into f of x y, f of y given x of y given 0.8 dy, that is equal to integral y into 3 by 17 into 5 y square plus 4 dy, the 0 to 1, the range should be 0 to 1, that is equal to, it will be like that, integral 0 to 1, 3 by 17 can be taken outside, and 5 y cube plus 4y, that's equal to 3 by 17 into 5 y raised to 4 by 4 plus 4 y square by 2, 0 to 1, that's equal to 3 by 17 into 5, when we apply limits, 5 by 4 plus 4 by 2, 5 by 4 plus 4 by 2, that's equal to 2 plus 4 by 4 equal to, that's equal to 8 plus 5, 13 by 4, 3 by 7 into 13 by 4, 3 by 17 into what, 13 by 17, 13 by 4. So this will be the value, expectation of y, and the notation should be, it should not be like expectation of y like this, expectation of y given x equal to 0.8 of y. Okay, thanks, that's all for now.